Dr. B here. It's time for worksheet 7.10. This is the covalent bonding worksheet number 1 where we're working on bond formulas. Humans are loaded with covalently bonded molecules. The world is full of them. How are they bonded together? To find the number of bonds in an element, well, it doesn't hurt to memorize some things. For example, hydrogen 1, oxygen 2, nitrogen 3, carbon 4, honk if you love chemistry, halogens 1, silicon we'll assume is the same as carbon 4, phosphorus we'll assume is the same as nitrogen 3. In other words, follow the column down and assume that it's the same. Now, in reality, once the D block kicks in the third shell for the D, but the fourth principal shell for it, if you're looking at the periodic table, things can get complex because you have unfilled D orbitals, and so other bonding combinations are possible. But this simple list is really handy. In fact, I would go so far as, if you want to take a note on the top of this worksheet, consider these like puzzle pieces. You'll probably be glad you did. I'll say the elements, and then we'll just talk about how to draw it. Hydrogen, 1 valence electron, so just draw one line. It tends to form one bond. What else do we see here? Oxygen, 6 valence electrons, so 2 lone pairs, 2 bonds. Nitrogen, 5 valence electrons, so draw 1 lone pair and 3 bonds. All the halogens, chlorine, I see. Fluorine, perhaps iodine, always 7 valence electrons, so touch 3 lone pairs in a line. These will be your puzzle pieces for sticking things together. Sulfur, we can assume to a first approximation, even though it does have available D orbitals, will form 2 bonds and 2 lone pairs. It at least is a good place to start. What did we miss? Anything here? I think that covers just about all of them. If you have those puzzle pieces listed, all you got to do is stick them together. Consider putting the thing that forms the largest number of bonds in the center and the other things like satellites around it. So we'll complete the table below to help with these bond formations. Hydrogen, valence electrons 1, therefore no lone pairs in 1 bond. Phosphorus, which is in the nitrogen group, that's group 5. If you use the electron dot structure, you'll see very clearly that it has 5 valence electrons, so somebody's got to double up. It will have 1 lone pair. That's there. It takes up space, but it doesn't participate in bonding. It'll have 3 available bonds. Oxygen, with its 6 valence electrons. Whoop, no, I skipped one. Chlorine, with its 7 available valence electrons, just like all the halogens, will have 3 lone pairs and only forms 1 bond. Oxygen will have 6 valence electrons, therefore 1, 2, 3, 4 around the square, if you will, with electron dot structures, and then those last 2 got to double up, so 2 lone pairs, 2 bonds. Silicon, 4 valence electrons, so the maximum multiplicity. It can form 4 bonds with no lone pairs. That should say 4. H2O, let's draw it. There it is. So just draw you would be drawing your puzzle pieces. Hydrogen with 1 line. Well, I draw oxygen in the center first. 2 lone pairs, 2 lines. Connect them to the hydrogens. Life is good. Nitrogen, N2. Well, but nitrogen likes to form 3 bonds. There's only one combination possible, a triple bond between the 2 nitrogens. Don't forget that lone pair that's always on nitrogen. Put carbon in the center for this one, and each of your oxygens as satellites on the outside. Carbon forms 4 bonds. There's no choice except to put double bonds on each carbon, and that makes oxygen fully satisfied. Oh, don't forget the 2 lone pairs on each oxygen. Nitrogen is the big bonder here. That's your central piece. Each hydrogen will have 1 bond attached to it. Don't forget that 1 lone pair for nitrogen. CS2, I think this would be entirely analogous to CO2. CHCl3, well, that's no problem. Carbon has 4 bonds to fill, and we've got 4 things to put on it. Don't forget those 3 lone pairs on each chlorine. H2S is just kind of like H2O, only with sulfur rather than oxygen. I believe this is one of the most putrid-smelling substances on the planet. So it's clearly different than H2O, isn't it? It's got an unfilled D block. C2H5Cl, chloroethane. I'll put the two carbons together, throw the chlorine on one side, that'll give you 2 bonds, and then populate it with those hydrogens such that carbon has its 4 bonds and life is good. Do not forget those 3 lone pairs that the halogens have. NHO, interesting. I think this can be accommodated as long as we put a double bond on the nitrogen and a single bond on the hydrogen. And that's right, don't forget the 2 lone pairs on the oxygen. Perfect. You can draw these with lines. Where are we here? There we go. You can draw these here and here with lines. In fact, I think you're better off doing that. It's simpler. SiC-Br6. Well, we're going to treat silicon and carbon equally. They're in the same group, group 4. So stick them attached to each other and populate the rest with the bromines. Is it enough? It is. Hey, there's a minor error. Can you see this? Technically, we are missing, I don't know, 6 times 6 valence, 36 electrons here. Every one of these halogens should have its 3 lone pairs. C2HF. That's interesting. I don't think we have enough substituents, so we'll have to use some multiple bonds. Bond carbon to carbon, draw hydrogen on one side and fluorine on the other, but I think even isomers are possible here, are they not? Maybe not, right? Because what would you do with that? You can't put the hydrogen and the fluorine on the same side. This carbon here, there'd just be a problem. So I believe this is the only way to draw this. And yes, you must draw your 3 lone pairs on fluorine. COS, well, it's kind of like CO2, but with a dipole moment, right? The oxygen is more electronegative than the sulfur. But I would draw double bonds. I'd rather do that than those 4 electrons, but that's fine. H2O2. Are isomers possible? I don't think so, because hydrogen has to be at the tip since it only forms 1 bond. So draw your framework, HOOH, right? Oxygen forms 2 bonds. You got to put it in the center. And then see if you need multiple bonds. You don't. Just remember your 2 lone pairs on each oxygen. Now this, you would need a double bond from carbon to oxygen. Otherwise, there's no way else to draw formaldehyde. And there's your 2 lone pairs on oxygen. Tell me about lone pairs for this guy. 0, 1, and 3. Silicon is your centerpiece. Draw the nitrogen, draw the chlorine. I wonder if there's options here. Can we put the... are we done? I think I left this one as an exercise. But if you draw silicon triply bonded to nitrogen, that makes sense. Nothing will attach to nitrogen. It forms 3 bonds, and this chlorine has to be attached to silicon. I don't believe there's any other way to do that. It's not drawn here, but I hope you heard the words. And don't forget your chlorine with 3 lone pairs. So to summarize, chlorine with 3 lone pairs, singly bonded to a silicon, triply bonded to a nitrogen. That's right, with 1 lone pair. And here's oxygen right here with its double bond, and each oxygen has 2 lone pairs. This is the covalent bonding worksheet number 1.